Thank you, Sergio, and thank you for inviting me here, having me here in this really extraordinary, beautiful city of Salamanca. And yeah, I'm Bruno Fierens, so I started my journey with Pascal language. It was back in the days in '86 to be precise, with the Turbo Pascal version 3, and I think I have used between '86 and now every possible Turbo Pascal and Delphi versions after that. And so today I want to give in this presentation where we, as the company TMS, which I started back in '95 when Delphi was launched, and meanwhile I was alone in '95. Meanwhile, we have our main team in Belgium, office in Belgium with 7 people, and also we have several people working from home, but from different places in the world, for the exact reason that people with very specific knowledge and expertise assist us with creating the products that we do from many places. So in total, we have a team of 16 people by now. So let's see how in this journey we, TMS as a company, tries to assist, help Object Pascal, Delphi, Lazarus developers to be more productive. And let's first maybe have a short look at a long period, 30 years to be precise, and the changement of the developer landscape from '93 till 2023. Who was still developing or already developing software in '93 here in this room? I see only a few hands, so okay, more hands, that's good. Otherwise I was starting to feel really old. But I think the main message is in 1993, when you mastered first DOS and then Windows development, you were pretty much the king of software development because you reached like 90% of computer users back then. The landscape changed quite dramatically now in 2023 when you see the number of platforms that we have to serve today to serve computer users. So obviously Windows is still important, but there is, I think Android surpassed the number of Windows users for a long time already. Apple with its platform macOS, iOS, of course also Linux is playing an important role. And not to forget the browser. So many people use the browser as their platform for accessing computer services whatsoever. And in terms of IDEs, I think also a lot changed over the years. Although I think Turbo Pascal was always revolutionary when it concerns IDEs. I still fondly remember Turbo Pascal for Windows that I have been using in '93 to create the first Windows applications. No form designer at that moment. We had to use the Borland Resource Workshop to create our forms and connect what we created in Resource Workshop with the UI logic. And nowadays, they are already, some people are already using Visual Studio Code in the cloud. No longer install the IDE on the machine, but just use it directly from the browser. So that's quite some evolution, I would say. Another, I think, huge evolution is what I call the moving from a computer island to a computer network. Back in '93, the only means for me to connect to the outside world was through a modem, and I had to save precious time to do that because it was a very costly operation to do that. But other than that, my computer was an island. Nowadays, every machine is connected to every machine in multiple ways. The internet, TCP/IP, of course, as a very important way to do it, but also think about Bluetooth, NFC connections, and so on. So all devices are connected to everything just 30 years later. But there are also things that did not change, I think, for us as Object Pascal developers, which is what we want to do, what we want to achieve, how we want to work as software developers. I think it still comes down to productivity. We want to achieve results, and we want to do that by writing code fast in a robust way, with readable code. I think that was also one of the main, and still is one of the main benefits of Object Pascal, that it is very readable code. And in doing so, I think as a programmer, we want to focus on our problem domain of what the application that we create needs to do, instead of focusing on the technical complexity that is behind it. Think about operating system, APIs, etc., that we are shielded as much as possible from these technical things underlying, and be as productive as possible as a software developer. And so where do we try to fit into that landscape and assist our users? And that is mainly through these, what we call the 4 pillars. It's actually the first page on our website, so that every time you visit it, you would see it and remember it, what our 4 pillars are, areas where we want to assist you, the Object Pascal developer, to be productive. And so that's of course for a long time already, from 1995, in the area of VCL. We also have the blue box, which is BIS and stands for everything that is related to business logic in more detail, to multi-tier database and also REST API server development. FNC is our umbrella for cross-platform development, later more on that. And as I mentioned on the very first slides, the browser has taken a significant portion of where users, computer users, find and use software applications all the time. So the web has become very extremely important, and so that is our 4th pillar. So let's come back to VCL. As I mentioned, I actually started with VCL component development back in '95. I created the first VCL components with Delphi 1. And first of all, these were mainly user interface components, and still till today, VCL plays a very important role in what we do with creating components, offering components. These are visual controls, a lot of visual controls, but it's not restricted to that. I'm thinking about libraries for serial communications, libraries for controlling security in your application. So there are many other areas outside just visual user interface controls. MQTT protocol is another communication protocol that is supported for VCL applications. So many areas of still, of course, VCL targets Windows, so that's also a key thing here, that this is for creating Windows applications, client applications. Second box, the blue box for BIS. We started developing this also, the very first developments in '98, with a scripter that is part of the BIS tools, so that you can write Pascal scripts that are interpreted at runtime, executed at runtime, and can interact with the native code in which this scripted engine is running. But it got, over the years, extended to a lot more. There is also our Aurelius object relational model, and that served as a basis to later create REST API servers that will couple to your database through this ORM. And this range of solutions is available to the major desktop operating systems these days, of course, Windows, Mac OS, and Linux. The third pillar is everything for web client development. And here, what we use underlying is actually the result, and we worked also together with the FPC PAS2GS team that you met during the previous session. And what we are leveraging here is the PAS2GS transpiler. And thanks to that PAS2GS transpiler, we are able to create client applications using Object Pascal and transpile that code, and that code will run as JavaScript code in any browser. And we have meanwhile hosted that framework, that web development framework, in 3 IDEs. So you can use that directly out of the Delphi IDE. It's also usable from the Lazarus IDE, and last but not least, we have also integrated this in Visual Studio Code. And that means that you can use the Object Pascal language to create web client applications on your favorite operating system, as Lazarus and Visual Studio Code run out of the box on a Mac, a Linux, and a Windows machine. And that actually brings Object Pascal code everywhere, because we have, meanwhile, on almost any device, decent modern browsers implementing the latest JavaScript standards that allow you to execute these web client applications. So you can see a myriad of devices here where these web core created applications, Object Pascal applications, will run on. How does such a web client application actually work? It has a similar architecture to what other JavaScript modern frameworks use, like Angular, which you are most likely familiar with, Angular, React, Vue, these frameworks. It works in a similar way. That means that your application is built out of JavaScript and runs in the browser, which you see on the left side. And this application running in the browser will communicate to a server, and that server can be based on any technology actually. It will communicate with that server through HTTP requests. And a typical scenario here is that you have a REST API server running, and so that will listen to the HTTP requests from the web client in the browser and respond, return data, update data, all these kind of things. And there exists also in Object Pascal many tools to create these REST APIs. So it's Object Pascal on the client, and it can be Object Pascal on the server. On the server, DataSnap was one of the first frameworks that offered creating such API backends, but meanwhile, Embarcadero Red Server accomplishes this. From our side, we have TMS Xdata, which is also a framework for creating REST APIs. But also in Lazarus, in the free Pascal community, there is something like the SQL REST client, SQL REST server, sorry, that also enables you to create REST servers that allow you to connect to databases on the server. So the architecture of how you create such a web client application running in the browser, as I mentioned, it is based on compiling Object Pascal code to JavaScript, which is done by the Past2JS open source compiler. And it goes hand in hand with also part of the Past2JS, what the Past2JS team has created, which is the Past2JS RTL. And you can compare the Past2JS RTL somewhat to what VCL is offering with the Windows unit, offering you access to the Windows API. In the same way, the browser can be considered as the operating system, and of course, from your Object Pascal language, you want access to that operating system, the browser, and access all the APIs that the browser exposes. And the RTL in actually the unit web.pas is the equivalent of what you have in VCL with the Windows.pas unit. But it's more than that. There's also all the functions that you are typically using from the RTL on a day-to-day basis. Things like date to string conversions, formatting, etc. JSON handling, all these things are available. And on top of that, with that transpiler and on top of the RTL, we have created a framework, a visual component framework actually, which you can compare with the VCL. We actually also tried to map this visual component framework as close as possible to the VCL framework. And the main reason for that is very simple. It is to reduce the learning curve. It is to allow you to reuse whatever you already had in code and leverage that to the web. And so that obviously includes components such as an edit control, list box control, memo, string grid, and so on. The components you are familiar with, you use on a daily basis with VCL or even LCL, and allow you to create with RED component-based methodology web client applications. That's what is concerning the web framework, but there is also an important part, of course, which is the IDE integration. So we integrated this complete workflow in the Delphi IDE, which means that you can create a new web core application. You have the visual form designer. From there, you drop the components on the form. You can manipulate the components with the object inspector, and also the Past2JS compiler is invoked from the Delphi IDE at the moment that you want to compile and run the application. And from the IDE, we also then trigger your favorite browser that will run your JavaScript application as JavaScript code in the browser. And this is another visual diagram how you can visualize this architecture of the framework. So at the bottom, everything is built on top of this Pascal to JavaScript compiler. It uses the RTL and all the web APIs that the browser exposes. And on top of that, we created this framework. For most part, visual component framework. There are, of course, also non-visual components, so such as a component to create HTTP requests, a timer, all these things. There's also possible to use jQuery controls from your web client applications. And finally, still on top of that, we have FNC for the web, but I come to that later in the presentation. And as you can see, this workflow is usable from 3 different IDEs. In terms of language, this is mainly, of course, determined by what the Past2JS compiler supports. And they achieved, I think, very close support for the language compared to Delphi or the language of Free Pascal. So it is nearly the complete language support that's there. There's things like RTTY, all usable from web client applications, generics, anonymous methods. There are, however, important to mark a couple of things that are not supported and that will actually never be supported. Just because the underlying browser, the JavaScript that runs in the browser, simply cannot and does not support it. And that is pointers, because the memory management in your browser is completely different from how it is in a native application. And because the memory management is completely different, there is also no such thing as getting size of types, such as an integer, Boolean, etc. I'm getting that question from time to time, that I have this record here, and my record consists of some data types. What's the size of these records? Records are supported in web client application. You can use them, no problem, but getting the size just does not make sense in a web client application, because the underlying browser JavaScript types that will be used to create that record have no meaning of sizes. Debugging is another important part that as software developers we all need to do from time to time. And so how is the debugging experience when you create a web client application with Object Pascal? Well, the Past2JS team has also done a wonderful job here of creating mapping files. Together with compiling your application, it creates a mapping file. A mapping file sets the relation between your generated JavaScript code and the original Object Pascal code. And that means that when you are in the browser, you open the debugger console, that you can actually see your Object Pascal code and step through this code at Object Pascal level, and can inspect variables, etc., all mapped on your Object Pascal code instead of JavaScript. You can still see, of course, the JavaScript that was generated, and sometimes that's very interesting to inspect, but as an Object Pascal developer, you will most likely have a preference to inspect it at Object Pascal level. One side note here is that Visual Studio Code is somewhat different. When you create your Object Pascal application in Visual Studio Code and you start the browser in debug mode from Visual Studio Code, Visual Studio Code offers the ability to debug, step through your code, inspect things directly from the Visual Studio Code IDE. This is because the Visual Studio Code editor has built-in communication with the browser for the debugging process. This is for now missing in the Delphi IDE and also missing in the Lazarus IDE. The good news though is that our team is working and actually already has a proof of concept where you can debug from the Delphi IDE. So your application is running in the browser, but there will be a debugging communication between the browser and the Delphi IDE, and so you can step through your code from the Delphi IDE. That will be coming later this year. We talked about web client applications all the time, but actually it's a broad term for different types of applications that are created with web technology. First of all, the normal expected thing is the web client application that runs in your browser. You navigate through some URL and your application gets started, executed in the browser, and that's it. But there is more than that you can do with web technology. A second category I would classify as PWA, which is progressive web applications. And with progressive web applications, you actually create installable and applications that can also run, if you develop them correct, applications that you can run offline, that can be used on mobile devices. That means that when you create a progressive web application and you open it on an Android device or an iOS device, it will indicate that this application is installable on your mobile device. And it will add an icon on the home screen of your mobile device. And from there, from that icon, you can start the application just like you can also run a native installed application. Actually, as a user, you do not see a real difference when you start such an application between a native application and a progressive web application. When you start your progressive web application from the mobile device, it will also run full screen. So no browser to be seen, no navigation bar, etc. It will run and behave as good as possible as a native application. And finally, two other categories of applications based on web technology. First is Electron. Electron is already around for some time, which is a framework to embed web technology-based created applications, embed that into a native application that runs directly on your desktop operating system. And as it runs on the desktop operating system, Electron framework enables you to directly access resources on your operating system. Think in the first place about the file system. So the file system becomes accessible to your web technology-based application. And many more services that the operating system offers you becomes accessible this way to your web application. We have also created Miletus, which is, from a technology perspective, quite similar to Electron. The major difference here is that when you create an Electron application, it will deploy a browser engine, the engine that is embedded in that native application, whereas in Miletus we just use the default, the standard operating system browser that is available, and which makes the total deployment of your application this way a lot lighter. Okay, and then the fourth pillar, which is the FNC pillar, and which is where we have all the code that for cross-platform native application development. And these components, the result of the FNC framework, is usable from Delphi, C++ Builder, Lazarus, and also from Visual Studio Code. Important to note, from Visual Studio Code, when you create web client applications with Web Core. So what is actually FNC? It stands for Framework Neutral Components. It offers a way to develop components that will work in a VCL, FireMonkey, LCL, and Web Core application from the same code base. And so that means that it saves us and you the work of creating different code for different frameworks for different targets. So with one code base, you can go anywhere. And that literally, I think these days means anywhere. It targets Windows, Mac, iOS, Android, Linux, Raspberry Pi, and of course also the web browser as an operating system. Why did we create that? Several reasons. With one way to create components and one component set that you can use everywhere, of course, you reduce the learning curve. Think about complex grid components. You will most likely be familiar with the learning curve that can come with such complex components. When you mastered it once, whatever the task is that crosses your path, you can use this component in the framework that you have chosen. And to a degree, actually, this is already the concept of what FireMonkey framework itself offers to Delphi developers, because the T-edit, the T-listbox, the T-memo, etc. exist in the FireMonkey framework and also in the VCL framework that was with the same ID, that what you have written for VCL, that you can reuse it as maximum as possible in the FireMonkey framework. And here, in this concept, you can, the difference here is that the code base is identical, and that as such, your user interface logic is also identical between these different frameworks. And this is the architecture. This is the diagram of how we created this FNC abstraction layer. So it is an abstraction layer, and if we code the FNC controls against that abstraction layer, that layer sits on top of VCL, FireMonkey, LCL, or our WebCore framework respectively. But if you build on top of this abstraction layer against the abstraction layer classes, that means that if you do that once, this component will work within these four frameworks. And as a result of that, there are actually four different categories of components that can be built this way. In the first place, non-visual components. A major part of it, user interface controls, also REST API access components, client components, and components that use or bring web technology in any type of application. That's a fourth category. And this is the series of products that we have meanwhile created on top of this FNC abstraction layer, and as a result that you can use in any of these frameworks for any of these target devices. And as I mentioned, these components are usable from, at this moment, 4 different IDEs and 4 different frameworks. A little bit looking under the hood of this architecture. Of course, we will use native controls wherever possible. So it's somewhat different from, but that's also changed during the years, where in the very beginning, the FireMonkey framework, for example, a T-memo was not in Windows based on the underlying Windows editor class. Here in FNC, we use the native controls, the native classes, wherever possible to give you the best possible experience on the operating system. And so underlying, we use the native controls, platform APIs, etc., including also in the browser, of course, when we want to use these components in web client applications. For non-visual components, not much to say here. The only thing that we add here are interfaces for automatic object persistence in JSON, for example. UI controls, here we have 3 main classes, abstract classes, on top of which we built the user interface controls, which is the FNC custom control class, and also the FNC graphics class. So if we code against these classes, descend from these classes, we are sure that these components will run on all the frameworks. Of course, there will be an implementation of FNC custom control that is tied to VCL. There will be an implementation that is tied to FireMonkey, one to LCL, and finally also one to our WebCore framework. And the same applies to the graphics component, which you can consider similar to the T-canvas, which is the object that you use to do all the drawing, and the same object for FireMonkey, for WebCore, that is all achieved this way. The FNC bitmap is a class that deals with images of various image formats, but when you use it, this class, you can also use the same code in all the targets with all the frameworks. And here is a summary I created of several visual components that have been achieved by writing them against the FNC abstraction classes, grid, tree view, planner, rich editor, and so on. Another category of components is components for REST client access. So think about HTTP requests and more importantly, HTTP requests that go through OAuth authentication authorization. So this is all built in and allow you to consume REST API endpoints of all kinds. And with the same concept, write the code once and use it everywhere. And a last category of components, which might be somewhat unfamiliar, but nevertheless with the growing importance, is components that wrap or encapsulate web technology. And as they encapsulate web technology, these are components that are built by running code into a browser engine. And when we want to take advantage of that in a native application, of course, it is important, it is critical that there is bidirectional communication possible between what is executed in your browser and what's happening in your native application. And that means that from the native application, we want to have the ability to execute at whatever time we want something in the browser, and that will execute as JavaScript code. At the same time, when something is happening in the browser, think about clicking on a button, for example, we want to be able to react from our native application, and so that means that from the JavaScript code that is running in the browser, it is important to trigger native code that is living outside this browser. A couple of advantages or things where this can be where this can offer interesting capabilities. Think about existing JavaScript libraries or services that are offered as web services. And the first thing that comes to mind, and the reason actually why we started this development, is because of mapping services. You all are familiar with Google Maps, Bing Maps, OpenStreetMaps, and many other mapping services. Well, these services are offered as services that run in a browser. And when you want to interact with that from a native application, that means that we want to take advantage exactly of this bridging communication, where we can, for example, instruct from our native application that the mapping service needs to pan to some specific location, or when a user clicks on the mapping service to start road calculation, for example, that can be handled from our native application. When we look under the hood of how this is at an FNC level created, well, the same story here. We reuse the default browser of the operating system, so no additional browser engine to install, and also taking advantage of all the browser security enhancements that come all the time automatically with the operating system. And so on Windows, this means, meanwhile, I think Microsoft started this initiative something like 3 years ago, moving from the Internet Explorer engine and actually phasing it completely out by now, to an Edge Chromium-based engine. WebView 2 is the name of the API to work with that. On macOS and iOS, it's the Safari-based browser that is used there. On Android is the Chrome-based WebView. On Linux and Raspberry Pi, this is the WebKit browser that comes with the operating system. And of course, when we want to use a web interface within a web client application, we have something like a browser in a browser, and that is accomplished through an iframe, so obviously no need to install or use a different browser. And here you have a brief look at the interface of the browser wrapping control. That shows you the bidirectional communication, where you have on one side execute JavaScript to inject and to execute on demand of the native application JavaScript running in the browser. On the other side, the registration of callbacks for JavaScript events that happen in the browser and to which you want to react from your native application. Question here that comes is, do we need to have our application to have it always online? And the answer here is that this browser wrapping component offers the ability to run both offline and online, but of course, for some things, it will not work offline because you use an online service like Google Maps that requires that you're online. But there are other JavaScript libraries that you can load, host locally, and that as such do not require that you are online with your application. And then the last thing that I wanted to bring to your attention is Miletus. I offered it or mentioned it earlier on in this presentation. So Miletus is actually a technology to let you create cross-platform desktop applications with web technology, with Object Pascal, and that you can, where you can reuse web technology. And actually, here is where this name is coming from. So Miletus is a Greek ancient philosopher, and the logo from Miletus is coming from a theater of Miletus, the theater where this old Greek philosopher used to tell his or share his knowledge with the audience. So what is the architecture? What does it offer? It is based on web technology, so that means that the browser engine is, or again here, a core part of what is happening. But still, we offer that you can use Object Pascal to create your web client application running in this browser. And so we leverage, again here, the Past2JS transpiler. Advantage to create nice user interfaces is that your browser will, out of the box, render whatever HTML5 and CSS3 that you throw at it. It will render it nicely in the browser. You can leverage existing CSS frameworks to make your application look good. And as I mentioned, also critical here is the bridging from the native application that is hosting this browser engine, vice versa. And it is through this bridge that we actually enable that you can use operating system functionality out of this application that is running in a hosted browser. So think again about native file access, using operating system dialogues to open files, to pick files, for example, the toast notifications, but also including access to local running databases, for example, which normally, when you run that from a standard browser, will normally not be possible. And so here are a couple of reasons why you would want to consider this technology. You might have interesting existing JavaScript libraries. Think about TensorFlow that was mentioned earlier here today for AI learning tools, etc. TensorFlow is available from the browser, so you can leverage that through this technology. And it is something that is also cross-platform, so when you create your Object Pascal code to run into that browser engine once, you can compile from, or better create from your IDE executables for 4 different operating systems. So actually using this technology, you do not really, but I recommend you do, need a Mac to create a Mac application, or need a Linux machine to create a Linux distributable, or even create a Raspberry Pi to create a Raspberry Pi application. And specifically for the Raspberry Pi, I wanted to mention that this Miletus technology also offers you to access the electronic peripherals that you can connect to your Raspberry Pi. Think about GPIO pins, SPI, I2C, UARTs. This is all accessible from this Miletus application running on a Raspberry Pi. And same story here, we leverage, we use the browser that comes standard with these 4 different operating systems. It's important to note that the Miletus shell application, so the Miletus shell that hosts this browser, that performs the bridge communication with that browser, and that offers operating system APIs, file system, database access, the electronics on the Raspberry Pi, that this Miletus shell application is actually created, of course, with Object Pascal. It is a VCL application when it's a FireMonkey application when you create it from the Delphi IDE for the 4 main operating systems. And for Raspberry Pi, this shell application was created with FPC, simply because FPC allows you to create native Raspberry Pi applications and gives you access to all these electronics. And with this, I think we are full circle, where Object Pascal is used everywhere. So it's Object Pascal that will run within as JavaScript within your browser engine, and this is hosted in an Object Pascal created application. So you basically use Object Pascal everywhere. And with that, I think it's still a valid conclusion to say that after so many years, I think it's astonishing actually that in over 30 years of Object Pascal development, we can still enjoy our reach, that whatever we technically want to achieve, that we can do that with our favorite language, Object Pascal. Thank you for your attention.